Alright, Assalamualaikum and good evening. Today we will start on the next lecture, which is condensation and boiling, lecture 9 and 10. Okay, topic to be discussed, a little bit of introductions, condensation heat transfer, boiling heat transfer, important region for boiling curve. So these are the four topics that we will discuss in detail. Okay, introductions. In the previous topic, we already looked on use of fluids as convection heat transfer in a single phase. Means the fluid remain unchanged from the beginning of heat transfer until the process is done. So now we will see convection process that associate with the change of fluids. The change of fluids, example of condensations and a boiling phenomena. Okay, an example of condensation and boiling phenomena happen in our daily life is in our air conditioning system, or in our refrigerator, where the refrigerant is changed from vapor to liquid and then from liquid to vapor. These changes are accomplished by boiling and condensations, and the engineer must understand the process involved in order to design appropriate heat transfer equipment. So, as engineer to be, we have to understand how does this boiling and condensation happen. Condensation and boiling is natural phenomena associated with the fluid property depends on its saturation temperature and pressure. So either or is depend on the temperature and the pressure of the fluids. Saturation temperature is temperature where the fluid starts change its phase at a given pressure. So what does it mean by this? Is the meaning of saturation temperature, where the fluid start to change the phase. Saturation pressure is the pressure where the fluid starts change its phase at a given temperature. Okay, that's the meaning. Next, condensation heat transfer. What do we expect if there is some cold material exposed to environment space? So what happens when you have when you box cold water and you put in room, for example, you could see that the bottle, the outer bottle is sweating. Okay, like this. So this is clear. So this answer is, this is what? This is condensation. Some water or drop of water will be seen over the surface of a cool material due to atmospheric mixture. So the water is not from inside to outside, the water is come from the environment due to condensation. This phenomena is called condensation. So next one is okay. Here, for example, we have a vertical plate exposed to condensable vapor. If the temperature of the plate is below the saturation temperature of vapor, condensation will form on the surface, and under the actions of gravity will flow down the plate. So what happens when we have a plate that the temperature is below the saturation temperature of the vapor? Condensation will happen towards the plates. So this condensation will happen in two ways. The first one is drop-wise condensation. The second one is film condensation. Okay, so there are two types of condensation. The first one is film condensation, where the liquid wet the surface. You could feel this surface is wet. A smooth film is formed, and the process is called film condensation, and the other one is dropwise condensation, where you could see the droplet of water that falling down towards this vertical surface. This is called dropwise condensation. Okay, if you compare these two type of condensation, the rate of heat transfer in dropwise is more than the film due to area is less. So if this is count which area is more, if we have a droplet here, you count this is x time, for example x time y. This one you cannot x time y because you have a bubble over here, so you need to count the area, and the area is much bigger than film. So when the area is more, heat transfer is also bigger. Okay, here I just jot down the formula, which is Q dot is equal to Ka dt over dx. Sorry, this is dx. So what happens when A is bigger, A is higher, Q also will be higher. So because Q is directly proportional towards the area. So this area is bigger, means the heat transfer also bigger compared to this one because the area is less. Okay, next one is boiling heat transfer. Boiling is liquid to vapor phase change. The process just like evaporations. Evaporation occur at the liquid vapor boundary where the vapor temperature is more than the saturated temperature of the liquid at the given pressure. So evaporation happens when the liquid vapor boundary, this is vapor over here, liquid down here, so you have a boundary at the middle. Let's draw this one. Okay, so you have a boundary over here. This below is liquid and this one is vapor. So evaporation happens when the liquid vapor temperature is more than the saturated temperature. So this one is higher, high T compared to this one. Okay, next example of evaporation are drying of clothes, fruits, vegetables, and boiling waters. So note that evaporation involves no bubble formation or bubble motion. So this is evaporates. So there is no bubble formation over here and no bubble motions. Okay. Okay, now let's look on the two types of boiling. The first one are pool boiling. In absence of bulk fluid flow, this is pool boiling. The another one is flow boiling, where there is forced convection boiling in presence of bulk of fluid flow. So over here there is no fluid movements. Here is the fluid is being moved, yeah, and being heated on the side. Fluid is moving. This is, for example, inside the air conditioning system, where the refrigerant is moved from one part to another parts. Alright, to study the boiling, there are some persons already study in details named Nukiyama. So in his or she's experiment, he used electrical heated nichrome and platinum wire immersed in a liquid. So Nukiyama noticed that the boiling takes different form depending on the value of the excess temperature. So depends on the difference of T excess. T excess is T surface minus T infinity. So this is different of T excess. Okay. Then she got this one. The important regime will depend on Ts and T sat, saturated difference. So for example, this is natural convection boiling, where the T sat, the difference is only 3 degrees Celsius. This is nucleate boiling, where the difference is about 10 degrees Celsius. So you could see this is nucleate happen. So this one is transition boiling, where you could see this is vapor pockets start happening. Okay, This is vapor, this is liquid. The pink one liquid, this is vapor. Yeah. This one is okay. The T excess, Ts minus T saturated is around 80 degrees Celsius. And then you could see this one is a vapor film or film boiling. You could see this is vapor or between the pot or the steel and the water. The vapor in the middle. Okay. There's no water at all. It's only all vapor inside here, and this is bubbles. Okay. Okay, and then Guillermo managed to get this kind of boiling curve regime. So you could see when the difference Txs is Ts minus T infinity is between 1 to 5. This is natural convection boiling up to A, and then A to B, where the difference is Ts minus T infinity is this one is bubble collapse in the liquid. It is actually nucleate boiling. This is a region where the bubble collapse in the liquids. There's a bubble, but the bubble is not going up. The bubble appear and then will be collapse. Okay, and then if the difference is bigger from this one is maybe 11 up to 30, so the bubble rise to the surface, to the free surface. So you could see that the bubble from the bottom up to the top of the waters and go towards the air. And then if the difference is between 30 up to 120, this is transition boiling, where the vapor start happening at the bottom of the plate. Okay, here vapor start happening. Okay, transition boiling. Okay, this is maximum critical heat flux. This is the point. What is it? Where Q is max. Q dot is max. Okay, and then before it goes towards the film boiling, there is a Leidenfrost point. Okay. What actually happened here? It's because of the this one, this film. So when this vapor film start to happen, there will be a drop of heat transfer. Yeah? This is where the vapor is still happen, and then it will until fill up the bottom of the plate. When it fill up the bottom of the plate like this, and this is it's not yet. This is vapor. This is liquid. This is vapor, liquid. So when it totally fill up, so what happened? It will create 100% gas. If this is 100% gas, this is stagnant gas. This stagnant gas will be a conductor. So it will be it will transfer heat from the bottom towards the liquids. Compared to this one, this is not yet, so it cannot transfer like the vapor films. Okay. Okay, the rest is just an explanation. So to further detail on this explanation on this curve, I will give you another video that gives detailed explanation about this boiling curve region. Alright, that's all from me. Thank you.